Hello students, welcome to IMS Academy. In today's session, we are going to discuss EDC subjects. This session is smart revision through formulae. But I am going to explain the concepts and also through what the concepts I will explain and what are those formulas are employed in the subject of electronic devices and circuits. I will do them. But this subject is for ECE students. They are going to get in the gate with around 8 to 12 marks. Minimum is 8 marks, maximum 12 marks you can expect from the electronic devices and circuits. But just I will give the concepts with the formulas I said there in the row. Here what are those topics we are having in EDC? Only 4 chapters we are having, 4 chapters only we can say. What are those chapters are there means only 4 chapters. One is said to be semiconductor and second one is said to be PN junction, third one is bipolar junction transistor, fourth one is metal oxide semiconductor FET, that is a MOSFET you know very well. But in the semiconducting materials you can expect 2 questions in the gauge, you can expect. Even and also you can give the much importance to the MOSFET also. In the MOSFET you can give importance to the MOS capacitor. And you can give the little bit of concentration on PN junction diode and also BJT. Understand my point now. Anyhow, I will give concepts and also the formulas which are employed in the first chapter of semiconductors. Initially, I wish to select the semiconductors now. Semiconductors, I want to select it first. This is the first chapter. What information I want to give here, you please listen. Solids are classified into 3 types. Every student know better. You will see the formulas also. Then slowly I will enter now. First I will give the slide concept. I will enter into the formulas now. Solids are classified into 3 types, you know. They are nothing but insulator, conductor, semiconductor. These 3 materials are very important in the engineering field, you know very well. But in electronic devices and circuit, you need to know the band energy diagram of the materials. So certain important points I will discuss in that energy band diagram, because every formula comes from the way this energy band diagram only. Maximum formulas I say, maximum formulas you can expect from the energy band diagram only here. Understand that? But you can find the 3 bands in conductor or insulator or semiconductor. One is a valence band, second one is a conduction band, third one is forbidden band also you can write. Otherwise forbidden energy gap or forbidden band also you can say. Very perfectly means 2 bands, valence band and conduction band. Otherwise we can say the gap between these 2 bands we can call forbidden energy gap also. Understand my point now. How that energy band diagram is to be drawn. You will draw for the 3 materials I will draw, you can understand. If you have taken well about the insulators, you will find energy band diagram in this way. This is said to be valence band. This is said to be valence band. This band is said to be conduction band. Conduction band we can call. The gap which is existing in between these 2 bands is said to be forbidden band or forbidden energy gap. energy gap. Also we can write. Here this energy level, this point energy level is said to be EV, valence band energy. That is maximum valence band energy only. What is the minimum value of the valence band? Means you can say minus infinity, I can put here now. This can be taken as a minus infinity. This point, lower energy level of conduction band, is called as EC, conduction band energy. It slowly rises and reaches to what? Infinite. Infinite level is possible now. So valence band is defined as, how you can define valence band? The band which is filled with number of valence electrons is called as a valence band. Whatever the conduction band, the band which lies above the valence band is called as a conduction band. In between these two bands we got a gap. That gap is called as a forbidden energy gap. I would like to denote the symbol of EG. E suffix G, capital G or small g, your choice. This is the gap. Sir, how I can determine forbidden energy gap? By using the mathematical formula. This lower energy level of the conduction band is nothing but the EC. Higher energy level of the valence band is nothing but the EV. The difference of these energies is said to be forbidden energy gap. I can say EG is nothing but EC minus EV. That formula you can use. I can write the forbidden energy gap is calculated by EC minus EV. This is one of the formula. Suppose in any problem EC value, EV value are given, directly you can calculate forbidden energy gap by using this formula. That is very important now. And still on the basis of the temperature also, you can write forbidden energy gap. That how that formula will be written now, I will give shortly now, understand my point now. For the timing, I can say forbidden energy gap can be calculated by EC minus EV also. But this forbidden energy gap is going to be changed based upon the type of the material, we can say that now. If you have taken the insulating materials, the gap will be around, but what is possible, 6 electron volts are possible for the diamond. Diamond is one of the example for the insulating material now. That is with 6 electron volts possible now. Understand my point now. More than 3.5 electron volts if you are finding, means you can say that is nothing but the insulating material only now. Forbidden energy gap is more than 3.5 electron volts only now. What about the conductor? If you have taken the conductor, we can't find any forbidden energy gap. We can't find. The gap is wide in the insulating material. If you have taken the conductors, you think it's so, that band will be drawn in this way. You can put from this point to this point, I have taken the conduction band. This is the conduction band I have taken here now. And valence band I can put like this now. This is said to be valence band only now. This will be drawn this side. So this side we can put like this now, best. We can put now. That means I say from this point to this point is said to be valence band. This point to this point I can call it as a conduction band. That means valence band and conduction bands are overlapped one over another only now. Just overlapping is done. Valence band and conduction band overlapped. So this portion is said to be, which portion? I will give clearly now. This portion we can call it as a, this portion only we can call it as a overlapping portion. This is overlapping portion. This is said to be overlapped. portion. This is overlapped portion, I can say. This is for the conductors, I can say. This is for conductors. For conductors. Suppose I ask, what is the forbidden energy gap? What forbidden energy gap existing in the conductors, I ask. We don't find any gap in between the valence and conduction bands. Those two bands are overlapped one over another now. So EC minus EV difference is not existing, directly 0 only we can say. I can write forbidden energy gap for conductor is 0 electron volts possible. That much is possible for conductors. This is for conductors only. But mostly in the competitive exams asking now forbidden energy gap for the diamond. If it is taken diamond, you can put directly for diamond insulator, I said now for diamond 6 electron volts possible. Forbidden energy gap approximately that is possible. That much valuable. But if you have taken semiconducting material, there we cannot find the gap of the more. Very less gap you can find. I can put diagram like this. For semiconductors, the gap existing between valence and conduction band is very, very less, very low level only now. The diagram I can plot in this way. This is conduction band. This is valence band. This is valence band. I can put here now. This is said to be forbidden energy gap, easy value. That is easy value for semiconducting materials. This is semiconductor. This is semiconductor one, you can say. Follow my point now? And I would like to give how to find out the forbidden energy gap for the semiconductors based upon the temperature. Temperature is changing means it is going to change. What are the good examples of semiconductor means germanium or silicon we can put only now. Suppose for the germanium, what formula you can use? For silicon, what formula you can use? I will give now though. So forbidden energy gap for silicon, if you want to find, for silicon I say forbidden energy gap is calculated by the formula 1.21 minus 3.6 into 10 power minus 4 into T. The formula is used. But it comes in electron volts only. Its value will be in electron volts. This is for silicon, I say. So this is the forbidden energy gap based what now given in terms of the temperature only now. That means the variation of the temperature can change the forbidden energy gap. Now try to understand here now, when the temperature is increasing more and more, the forbidden energy gap is going to be increased or decreased. You can check by using this formula. In case this temperature is increasing, you think it's so. This value will be increasing. The difference will be decreased, or you can say only now. Forbidden energy gap is decreased. There's a variation of the temperature is going to change the forbidden energy gap only, we can say. This is for germanium. If it is for silicon, for germanium, what formula we can use for germanium? In the problems, you will give sometimes when T equal to 400 Kelvin, but T must be in Kelvin, that is very important now. T must be in Kelvin. Kelvin is must. If it is not in Kelvin, not allowed. Suppose you are given in centigrade, you think it's so. You convert into Kelvin. You can use this formula directly. If it is for germanium, you think it's so. For germanium, you can use this formula. Forbidden energy gap is calculated by 0.785 785 minus 2.2, 2.2 into 10 power minus 4 into T. This formula is used. You must use this formula. 785.2.10 temperature. You will get in electron volts. So you have to mark up these two formulas for now to find out the forbidden energy gap. Suppose in a problem, but sir, you gave already EZ is nothing but EC minus EV. If you are given EC value and EV value, you can use that formula. In case you are not given EC and EV values, you are given the temperature now. In that case, we need to apply these formulas. These are the formulas I can say now. Understand my point now. This is the information regarding the what now? Forbidden energy gap. Understand now. Now the transport mechanism of conductor is more important now. Based upon the transport mechanism of the conductor, we are going to get the different parameters for now. Those formulas will be useful maximum in the semiconductors. I will give you now. Transport mechanism. Transport mechanism. Mechanism of conductor. First, initially you must know transport mechanism of conductor. From that, I can give transport mechanism of semiconductors also. Understand my point now. Certain definitions are more important now. Using those definitions, we are going to create the formulas here now. Mobility. First parameter required is nothing but the mobility. It is denoted by symbol mu. In a conductor, you can find electrons, only electrons you can find in the material. Whenever you are giving the supply voltage, flow of electrons possible now. Mobility of electrons are possible to cause current in the material only now. So anyhow, I selected one metal. It's a conductor. I have taken like this now. This is the conductor. This conductor is not connected by any external supply. No supply is there. Unbiased conductor I connected here now. But what is going to happen now? In that material, you can find excess number of free electrons are the more only now. That means even even you are not giving any supply, what is going to happen now? Electrons are going to move in the material. How they are going to move? Irregularly. Understand? That means in the conductor, when the supply is not connected, their motion will be in different path. They may go in any direction. No regular path. Any direction they will select only now. This is figure 1. Figure 1 I have taken without connecting any supply. What I did, I have taken same conductor. This is connected with a source. I connected one source like this. Some voltage I connected. The length of the conductor I have taken L. This length I want to select as a L. In this case, how electrons are going to move in the conductor? All the electrons will have motion in uniform direction. Like that, electrons are going to move. Like that, they are going to move when the supply is connected. This is figure 2. By using these two figures, I would like to explain the mobility. Mobility means what now? Free movement of electrons. Free movement of charge carriers, very perfect one. The charge carriers may be electrons possible, otherwise holes may be possible in the semiconductor. There is a free movement of the charge carriers in the material is called as a mobility only now. That the degree of that mobility is a higher or lower is calculated by what formula? That is very important now. If this conductor is not connected by any external supply, electrons are going to move in a irregular path or in a zigzag path, I can say exactly now. In a zigzag path, all the electrons will try to move now. They don't have any regular path. What is the total current is passing because of the what now? Irregular movement of the electrons? 0 only. If you connected any ammeter, it can't show any reading only now. Understand now? Because electrons move, one electron is moving this side means it is going to hit any other atom, immediately they will come back to backs, it bounces back only. Finally, total current will be cancelled only now. Anyhow, if you are connecting the what now external supply in this way, what is going to happen? We got the polarity. This is minus, this is a plus. Because of this polarity, what is going to happen now? Already this conductor is with number of electrons. Electrons are negatively charged particles. Negative, this is a negative, 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 repulsion, force of repulsion possible. Because of the force of repulsion, electrons are repelled, they are going to move this side and attracted by the positive electrode. Catch my point. Negative electrode is going to repel the electrons. Those electrons will try to have a motion in a straight path and they were all attracted by the positive electrode only, you can say. Now the regular path is possible here now. Now this moment of electron is said to be with what velocity these electrons are moving? Drift velocity, they will say. Because of the electric field intensity developed in the material, what is going to happen? These electrons are going to move only now. That what now? Mobility, what now? This velocity of electron is said to be drift velocity only. This is called as a drift velocity. With the drift velocity, electrons are going to move in a straight path. Now the point what I wish to say, velocity of these electrons, what velocity? I said drift velocity only. V suffix d allowed, otherwise V I have taken. V or Vd, your wish. Velocity of electrons is directly proportional to electric field intensity only now. Electric field intensity. There is a V proportional to E is more important formula. V proportional to E means what is V? V equal to mu into E possible. Where mu is said to be mobility of electron. Where mu is mobility of electrons. This is required. Mobility of electrons, I can say now. Mobility of electrons, I can say. Mu is the mobility of electrons only. So finally, if you want to find the mobility of electron mu value, you think it's so. You must use V by E. Drift velocity by electric field intensity. The formula you must know to find out the mobility of electrons. Sometimes in the electronic devices and circuits asking units also. Without knowing the units, we can't do anything now. What are the units of the mobility? Velocity means you know meters per second, otherwise centimeters per second allowed now. I am taking now meters per second. Meters per second is possible. But electric field intensity means you know very well. Electric field intensity is calculated by voltage by distance between the 2 points of the conductor, V by L generally used, voltage by length of the conductor. That is electric field intensity. Units of the electric field intensity use V is nothing but volts, L is nothing but meters, volts per meter. Volts per meter we can write. Finally, I am getting meter square per volt second. Meter square per volt second is allowed. So units of mobility, if you are asked in any paper, you can say meter square per volt second. Otherwise, centimeters per cm square per volt second also accepted. These also accepted. Like that, mobility is calculated only, you can say. Understand now. So mobility equal to drift velocity by electric field intensity. Electric field intensity equal to voltage by length of the conductor only, you can say. Understand? That way we can calculate only. Next one. One more point I want to give here now. To find out the mobility, I gave the what now? The formula only now. Sometimes you cannot find the velocity and also electric field intensity. In that case, how I can determine mobility, sir? Well, there is one more formula to find out the mobility of the charge carriers. Whether it is an electron or hole, it doesn't matter now. You can use one more formula also. That formula I want to give in your hand. Or one more formula. Mobility can also be calculated by one more formula. Second formula I want to give here. This is the second formula. The last one is nothing but this is the first formula you can use now. This is the first formula. This is nothing but the second formula. Mobility is a mu, whether it is electron or hole, no problem. That is to be calculated by charge into Q into tau divided tau. I say this is the tau. Tau divided by mass of, if it is for electron, mass of electron. It is a mass of hole means MP. I have taken the mobility for the electron. It is a commonly I want, sir. Commonly if you want means you can put it, no problem. M may be electron, what now, mass of electron. What M only, not only. M asterisk means still good. Why M asterisk, sir? M asterisk means effective mass of electron only, we can say. Understand? If it is in the vacuum means mass is taken M. It is a what now, air whenever it is taken, because in the air you can find the what number of forces to be acting on the what now, electrons only, you can say. The time mass on the mass of the electron, M asterisk. M asterisk means effective mass of electron, I can say now. Q means we know charge of electron or hole. What about the tau, sir? This is a tau symbol we are using. Tau is nothing but in the conducting materials, whether it is a conductor or semiconductor or whatever it may be, it doesn't matter now. Electrons are going to move in the material. When they are moving in straight direction, what they are going to do, they will collide with the what you can say any other electron only now. Before the collision of electrons, what time period that electron is going to move freely in the material? That means between the two collisions, how long the electron is going to move freely is said to be the what now? Mean lifetime of electron or hole only, you can say. Tau is said to be the time period electron freely moves between two collisions only, between the collisions only, I can say now. Understand now? Suppose one electron is moving from here. It is going to move before the collision. Once the collision is done, suppose it is hitting one more electron, you think it's so, collision is done. But before collision, what happened now? Some time period it is going to move freely only, you can say now. Freely they are going to move. That time period only you can say mean free time of electron, denoted by symbol tau. Understand my point now? Otherwise, still easy way we can say. Still easy way we can say this point. How we can say? When the electron is going to move in the semiconducting material, you think it's so. It is going to trap in the hole. Before trapping into the hole, it is a free electron only, we can say. But how long the electron will be free before recombining with the what now hole is called as a mean free time. In different way also we can define only now. So tau is nothing but the mean free time. This is to be taken as a mean free time. Mean free time. Mean free time of electron or hole only now. Understand? It is a commonly I have taken now. Mean free time. Understand now? That is taken here now. It is in seconds only. Understand my point now? You can take it in seconds. Next one. The mass whenever you are using, it must be in what now? Seconds not allowed now. It must be in the what now? What is required? Minutes only required now. The tau must be in minutes only, where when you are using the mass. Understand my point? That is very important. The next one. So anyhow, we got some information regarding the mobility. Understand now. After mobility, what is required? Current density. I want to give here now. Current density. Current density in a conductor. It is denoted by symbol J. J is the current density of conductor. So number of formulas you will see here now. Understand? I will explain clearly. You will understand now. I selected here one semiconducting material. Sorry, one conductor I have selected. I selected one conductor. It may be a silver or copper or anyone. You can take it now. This one is connected with a supply. Supply is connected like this. This voltage is V. The length of the conductor I said already L. This is L. This is a negative electrode, this is a positive electrode. There are number of free electrons in the conductor. Due to repulsive force from this negative electrode, electrons will try to move in this direction. You know very well, already explained. These electrons can have the uniform path and they were all attracted by the positive electrode. When the flow of electrons are taken place, you can find current density in the material. Current density you can find in this conductor because of the connection of the supply. Understand my point now. So current density can be taken by the formula current by area. Current by area of cross section of conductor. That formula is more important. Current by area. Current by mathematically just what now? Current by area means how you will denote, sir? Current we can denote by I divided by area. I can take A. I by A. So what units you can give for the current density? Current in amperes. Current must be in amperes. Area must be cm square. Amperes per cm square allowed or amperes per meter square also accepted. We can take such a way. Still, suppose in a problem you are given current and area of the conductor is semiconductor is given. You can use this formula to get the current density. In case you are not given current directly, what way we can calculate? Current can be calculated by, current is nothing but charge by time. Charge divided by time. By using this formula, you can determine current. Charge by time. Charge by time is how the formula will be formed here now. Charge means you can use the formula E. E is the charge or Q. E or Q allowed. Charge can be taken Q or E. Okay, you can put Q otherwise now. Otherwise E you can put, no problem. How many number of charges are moving this side? Not a single charge. Number of charges are going to move in this direction. When the number of charges are moving, charge can be taken N into Q or N into E. N into Q or N into E. Q equal to E I have taken here. N means number of electrons. Number of electrons are going to move in that material. Number of charge carriers divided by time. By time. But the time can be calculated by different way. We know from the mechanics what distance equal to velocity into time. One simple formula from the physics, otherwise you can say not only mechanics, physics and you know very well. Distance equal to velocity into time. Distance is nothing but the L. Distance between 2 points of the conductor is nothing but the L. Distance equal to velocity into time. V into time. I can write directly. But I wish to find what is the time T. T can be taken by L by V. We can use. So time is calculated by this formula. So I can write the formula here like this now. The current I can be taken as a L by V, NQ. This I will put as it is. divided by T. T is nothing but L by V. So, you can use this formula also to measure the current. How I can find the currents are N into, N means what I said, number of charges, Q means charge of electron here, V is nothing but velocity of electrons only, you can say velocity of electron only. What velocity? Drift velocity only possible there. Understand my point now. So, you can use this formula for the current now. Now, we got one more formula here. This is the current formula. Now, current we calculate, current density you can change, current by area is nothing but the current density only now. I can write current density is nothing but current by area. Current can be taken N into Q into V divided by L. This is nothing but current only now. Area is nothing but the area. A. You know very well. Length into area equal to volume only. Still we can modify. I can write length into area equal to volume I can put now. This is the volume. Now, this formula current density I can write this way also. You can find current density I want to calculate sir current by area. Possible. Sir current equal to what sir? How you can measure N into Q into V by L only now. So, then current density means you will get now current and area only now. So, directly formula I want sir, yes you can take N into Q into V, L length into area equal to what? Volume only. N into Q into V by volume I have taken here. I cannot put that volume equal to small v, I cannot put. If I have taken small v, students will say, sir already you gave velocity sir. I cannot put volume equal to capital V. If I selected capital V, students will say, sir already it is a voltage V sir. That is why I do not want to put any symbol. Directly length into area, volume only you can say. We know one more formula we can get from this EDC subject. Number of charges per volume equal to concentration. One more formula that is very important now, because in the problems useful every formula. Number of charges per volume. Number of charges per volume equal to concentration. There is one formula. You must mark up this formula, concentration. I can put here now. So, number of charge carriers per volume is N per volume, capital N by volume. I want to use N by volume I have taken. N by volume I have taken concentration, that is denoted by symbol small n. N is said to be concentration. I said now this is the concentration. What concentration? Electrons concentration, N I have taken now. Electrons concentration, because it is a conductor only. The conductor, what concentration I can have? Electrons concentration. Electrons concentration. Now, finally, I can write current density by using this formula. I can give the formula for the current density. What formula I can give? The J equal to N per volume, N small n into Q into V, N Q V. N into Q into V. Yes, this is one more formula. So, units I gave it amperes per cm square or amperes per meter square I said now. So, concentration into charge into drift velocity is nothing but the current density only now. The one more formula you can create from this now. N is the concentration, Q is said to be charge. The product of concentration and charge is called as a volume charge density. We can write now volume charge density also allowed only now. Understand now? This is a volume charge only. N into concentration into volume charge density of electrons only now. Volume charge density of electrons. N into Q, the product of N into Q. Understand? Anyhow, that point remember. Anyhow, you know, this formula still I can write if you want. N into Q into velocity equal to, we know very well. Already I gave velocity equal to drift velocity equal to mu into E. Already given. mu into E. So, I can write V is nothing but mu into E. But it is a conductor. If it is a conductor, mu n also allowed. Mu n means mobility of electrons. I can say, no. Anyhow, mu I have taken mobility of electrons now. So, I can use this formula also. So, how many formulas I gave it? You watch it now. Current density equal to what? Current by area. What is current, sir? N into Q into V by L. You can use. But this is one more formula we have taken. Current. Current density means finally we are getting the formula. What formula we are getting? This formula only now. NQ into V. The drift velocity directly given this formula. In case you are not given the drift velocity, in that case mobility is given, electric field intensity is given. You can use this formula for the current density and stand on. And one more point I want to give. N into Q into mu. Catch my point. N into Q into mu. N into Q equal to, I said already, volume charge density of electrons into mobility mu. NQ means charge density into mobility is called as a conductivity. One more formula. Conductivity equal to, I want to give one more formula. I want to give one more formula here like this. Conductivity, one more formula. Suppose in a problem, what is the conductivity of electrons in a conductor, you are asked? Conductivity. That is denoted by symbol sigma. Sigma symbol is allowed, small sigma. Capital sigma means they will put something different. Conductivity means what you can define now? It is the product of equal to product of charge density. Charge exactly means charge density, clearly you write. Charge density into mobility. Charge density into mobility. As a volume charge density, I said. Charge density means N into Q is nothing but the charge density only. Product of charge, that's why you can write product of charge density and mobility only. The finally conductivity I can write product of charge density. Charge density means N into Q. Mobility means mu. Yes, you can use this formula to find out the conductivity. So, conductivity is calculated by this formula. What units you can give? Mho per centimeter or ohm per centimeter also acceptable. Sorry, mho per meter also allowed. Sorry. Mho per meter also allowed. Mho per meter also acceptable only now. So, conductivity, if you want to find this formula. So, conductivity equal to N into Q into mu is one more way you can define current density. Mobility, what now? Conductivity into electric field intensity is nothing but the current density only now. So, if I substituted this symbol, still I can write current density by using this formula. N into Q into mu is nothing but sigma into E. Sigma into E can also be said as a current density. In how many ways you are getting the current density, you ask. Sigma into E, otherwise NQ into mu into E or NQ into V, like this, so many formulas are there now. Same point. Yes, I gave the explanation for the current density only, you can say. And sometimes you will be asked in the problems, resistivity of conductors. Resistivity is nothing but the reciprocal of the conductivity, you know. If you reciprocated this sigma value, you will get the resistivity only. I will give now. Resistivity, next one. If you wish to find the resistivity, it is denoted by a symbol rho. Rho is the symbol is used to find out the resistivity. Resistivity equal to, we can say, reciprocal of conductivity. Reciprocal of conductivity is said to be resistivity one. Conductivity means we got already, what I got? N into Q into mu. So, that formula you can use. If you are given concentration of electrons, mobility of electrons, you can determine rho, because charge 1.6 into 10 power minus 19 coulombs. By using this, you can get the rho one. What are the units of rho? It is taken ohm centimeters. Ohm centimeter or ohm meters. Anyone is allowed to find out the resistivity. Resistivity of the conductor or semiconductor can also be calculated by one more electrical formula. From the electric circuits, you know one more formula. Resistivity is also calculated by the formula What formula you can use? The rho equal resistance R equal to resistance equal to very well, resistance of the material. Resistance R equal to rho L by A. So rho, suppose sometimes directly, but a rho means N Q mu you will not be given those terms only now. But R, L and A values will be given sometimes in the problems. At the time you can find resistivity by using this formula also. Rho equal to RA by L. This formula also you can use to find out the rho value. So this is one more formula. I hope you follow. The next parameter. So far what I explained. In the energy band diagram, how to find out the forbidden energy gap, I explained. Next level what I did now. By using the temperature, how to find out the forbidden energy gap for the germanium and silicon, I gave it. Next one, in the transport mechanism, I explained what is the mobility. Two formulas I gave it here now. And second one, what I said, next one, current density, how to find. In different ways, how to find out the current density, I gave it now. That is also over. After current density, I explained what I explained here now. How to find out the conductivity of the material only now. After conductivity, I explained here now what is the resistivity also. These are all the parameters I explained in the conductors only. These will be useful in the semiconductors. How they were all useful, I will explain now. Now, the transport mechanism of semiconductor, we can take it now. For semiconductor, if it is a semiconductor, for semiconductor, I want to find the current density value also. How we can find the current density here now? Current density is nothing but the current density, because the semiconducting materials can contain concentration of electrons and concentration of holes also. Because of the movement of these two charge carriers by the connection of the supply, current density is going to develop only, you can say. What is the total current density in the semiconductor? If I ask, anybody can give answer very easy now. Current density due to electrons plus current density due to holes. When the addition of these two are made, you are going to get the required value. I say, for semiconductor, I can say total current density, how we can measure? Total current density. The total current density in the semiconductor is denoted by J. The summation of current density due to electrons, Jn plus J suffix P, you can use. Jn plus Jp, you can use only now. That is the total current density now. Jn means current density due to electrons. N is denoted concentration of electrons. P is denoted for concentration of holes only, you can say. That is the total current density now. Finally, what is Jn here? What formula you can use? But in the conductors already I gave it current density. That only Jn. N into I gave already. What formula I gave it? Current density is calculated by what formula? N into Q into V I have taken for example. N into Q into V. N into Q into V. V is the velocity of electron, Vn I have taken, velocity of electron. But here, what I can put here now, for holes, current density I can put P into Q into Vp, velocity of holes, drift velocity of holes. I want to denote only, you can say. But N is the concentration of electrons. The V equal to we know very well, velocity equal to we know very well. Velocity equal to already given mu into E. Mu means I can say J can be taken as a N into Q into Vn equal to mu means mu n, mobility of electrons into electric field intensity. Here the P into Q I can note down. Velocity of holes mu P into E I can write. Mu P into E I can write here now. And finally, what is the total current density I can get here? Here I can take Q into E is taken common. Q into E is taken common. I am getting here now N into mu N plus P into mu P. P into mu P. Yes, this is the total current density is possible. Total current density is taken that way, you know. N into mu N plus P into mu P. You know. There is a total current density in semiconductor. But in the semiconductors, you know very well, different types of semiconductors you got. Intrinsic semiconductor and extrinsic semiconductor. Suppose initial I am giving, suppose it is an intrinsic semiconductor. Intrinsic means pure type of semiconductor is said to be intrinsic semiconductor. In pure type of semiconductor, you can find concentration of electrons and concentration of the holes are equal. That's why I can write for intrinsic semiconductor. Suppose I have taken for intrinsic semiconductor. What formula you can use? For intrinsic semiconductor, you know very well. Concentration of electrons equal to concentration of the holes only. How concentration of electrons and concentration of the holes are equal? There is a valence band, next one is the conduction band. In the valence band, all the number of electrons are initially in the valence band. When temperature is given, number of covalent bonds are broken in the valence band. Electrons will be liberated from the valence band. Once the electrons comes out of the valence band, they are not going to stay in the forbidden energy gap. Directly they were reaching to the conduction band only. Once the liberation of electrons are made, they go directly to the conduction band itself. Directly they will go only now. How many number of electrons are passing to the conduction band? That many number of vacancies are creating in the valence band only now. The given name for the vacancy of electron is nothing but the hole only, we can say. That's why for intrinsic semiconductor, concentration of electrons N equal to concentration of holes only now. And one more way you can define, N and P values are equal. N equal to P equal to, I want to denote one more symbol in the formula, Ni. Concentration of electrons equal to Ni. Concentration of holes equal to Ni. Where Ni is given a name, intrinsic concentration. It's given a name, intrinsic concentration. Intrinsic concentration, such a way name is given. But a Ni depends upon two factors only. Intrinsic concentration always depends upon the two factors. One is nothing but the type of the material. Second one is nothing but the temperature. Whenever the type of the material is changing, germanium, suppose you have taken the semiconducting material. For germanium, some value of Ni. For silicon, some value of Ni. Even the variation of the temperature is taken place, Ni also changes only now. How that change is possible? In the next class, I will discuss that point only now. The Ni in terms of the temperature, I will give the formula. Then you can understand how the variation of the temperature is going to change intrinsic concentration, you will learn only now. But here the point what I wish to say is, for intrinsic semiconductor, concentration of electrons equal to concentration of holes, that equal to Ni. So if I substituted wherever, if I substituted N equal to Ni, P equal to Ni, how we can reduce the formula? You please watch. current density I can write like this also. N equal to Q into E, I can write here directly, Q into E I can put here. The N is nothing but Ni into mu N plus the P is nothing but the Ni, that also Ni, intrinsic concentration, into mu P I can note down, into mu P. Now, the finally current density, total current density is nothing but Ni is taken common, Ni into Q into E into mu N plus mu P I can note down here now, into mu P. So, this formula you can use to find out the what now? To find out the current density in intrinsic semiconductor, I can say. For intrinsic semiconductor, you can use this formula. Suppose the total current conductivity in the semiconductor, if you want to find, what way we can find? Current density means this formula. Suppose you want to find the, suppose you want to find total conductivity in semiconductor. Conductivity in semiconductor I want to find. In semiconductor. In the semiconductor, total conductivity I want now. Total conductivity in a conductor is nothing but summation of conductivity due to electrons and conductivity due to holes now. Sigma n plus sigma p equal to sigma I can put here now. I wish to write sigma equal to what? Sigma n plus sigma p I can write. We know very well sigma n, conductivity due to electrons I gave it, charge density into mobility I gave it. Charge density is nothing but nq into mu, here the mu is nothing but the mu n. For the holes, p into q into mu p I can write now. What I wish to say, the total conductivity I can get n into q into mu n. This is for the electrons, conductivity due to electrons. Conductivity due to holes means in the place of n, I can put the p into q into mobility of holes I can write. This is the general formula. Whether it is an intrinsic or extrinsic is not the matter. Directly by using this formula, you can find out the total current density only now. Total conductivity it says now. In case the given material is an intrinsic semiconductor, at the time what way we can find out the conductivity, you please watch now. Suppose for this is conductivity for the semiconducting material. It is not the matter whether it is a intrinsic or extrinsic now. For intrinsic semiconductor, I say, for intrinsic semiconductor, I said already, for intrinsic semiconductors, concentration of electrons equal to concentration of holes equal to Ni, already given. I said already, once again I am writing here now. Ni depends upon what I said. Intrinsic concentration depends upon, Ni depends upon, I said already, type of material. Material is changing means Ni also said type of material and temperature. It's very important. And temperature I can. It depends upon these two factors only you can say. Now we can write formula like this now. N equal to P equal to Ni it says now. I can write total conductivity is nothing but N equal to Ni into Q into mu N. P equal to Ni into Q into mu P. Finally, I want to find out the total conductivity. Total conductivity means Ni into Q is taken common. I will get mu N plus mu P I can write now. By using this formula, you can find out the conductivity in intrinsic semiconductor. In intrinsic semiconductor, you can calculate total conductivity by using this formula only now. So I explained for the conductors what are the parameters are having. Even for the semiconductors, I give the certain parameters only. You need to understand again one more law is more important, mass action law. By using the mass action law, some simplification of the work is done here now. But what is the purpose of the mass action law? What is the formula it is so used? How that formula will be employed in the semiconducting material, I will explain. That will be done in the next class. Don't miss the class. Attend tomorrow and try to get some information. I say, thank you.